Good morning, good afternoon. Thanks for attending the Oracle Integration Success webinar. I'm Jürgen Kress, part of the Oracle Product Management team. In case you missed one of our webcasts, on-demand recordings are available at Oracle Video Hub, including presentation for download. In today's presentation, Jake Patterson, an AI and integration specialist from Boxfusion, will present a customer case. Good morning, Jake.
Morning, Jürgen.
So you're working for quite a long time in the Oracle integration space.
Quite a while, yes, in a number of different Oracle technologies over time.
What makes this customer you're going to present today special, and what have you achieved there?
I think it's just been a really unique use case, very innovative, using all of the sort of latest technologies that are available to us. And I think the end result for their customers is a really great experience.
Excellent. So you will talk about artificial intelligence.
Yes, a little bit, yes, along with all of the other services that go into making those projects a success.
Cool. Thank you. So Oracle integration is a platform to connect SaaS services like ERP, HCM, CX, and custom-built applications. We offer certified adapters and pre-built connectivity. Objective of today's call is to introduce a success story and to show some best practices. Quick housekeeping, this session is live and the presentation is recorded. Please feel free to post your questions via the conference Q&A tool in the Zoom console. At the end of the webcast, we will answer them. Slides and an on-demand webcast will be posted at Oracle Video Hub. We will post announcements and links in the conference chat. Please complete the survey at the end of the webinar. As we might present some looking forward information, please pay attention to the safe harbor statement. For today's agenda, I will kick off the webcast with some quick announcements and then hand over to Jake for the customer case. At the end of the webcast, we will answer your questions. If you would like to try Oracle integration, it's part of the Oracle Cloud Infrastructure free trial, and you can try it for up to 30 days free of charge. If you use the free trial, please take a look for Oracle Live Labs, which are part of the documentation. Those live labs help to build your first proof of concept. If you're looking for integration experts like Boxfusion, you can search at Partner Finder and you find the certified partners in Oracle integration. At the Oracle Cloud Marketplace, you can also look up third-party adapters and you can publish your own adapters and recipes. If you have questions, if you need support, or you want to collaborate, please visit Cloud Customer Connect. There you can also earn badges for your reputation. We offer different certifications for consultants like the Sales, Solution Engineer, and Implementation certification, which are now updated to the 2025 release. If you look for the latest product information and product roadmap, we host a webcast each quarter with the upcoming features and new functionality. The last webcast from March is available on demand, so please visit OIC webcast March 2025, and there you find also the June webcast. All webcasts are recorded and published at Oracle Video Hub and are available for on-demand view. For details and upcoming events, please subscribe to our quarterly newsletter. There you can also find more success stories, best practice, and technical information. With that short introduction, I would like to hand over to you, Jake.
Great. Okay. Hi, everyone. As Jürgen said, my name is Jake Patterson. I'm a principal consultant at Boxfusion Consulting. I specialize in OCI technologies with a particular focus on AI services, including ODA and conversational interfaces. So today, I'm going to talk to you about a solution we've implemented for one of our manufacturing customers, which has provided an advanced AI-powered RAG system to help their customers with self-service requests. I'll start by giving a brief overview of the solution itself and a quick video demo as well, so you can see what that experience looks like from the end customer side. And then I'll talk through the technologies and some of the infrastructure that was put in place to support that solution. So I'll give an overview of the various technologies that are involved, and I'll also do a bit of a deeper dive into some of the technologies themselves, why we chose them, and sort of what considerations and implications came about from those choices. So first, to introduce you to the project itself, the intention behind it was to provide a more modern customer support portal with advanced AI features to allow their customers to self-serve much more easily than they were able to do so before. So to do that, the portal would have both a chatbot and a powerful search feature, both powered by the same underlying RAG AI tool. And that required us to build a new architecture in OCI to support that. And that was needed to support both the ingestion of content from various sources, which would form the knowledge base for the AI search, as well as an entirely redesigned portal, customer portal, to provide a more modern, easier to use and sort of search first user experience. So I'll start with just a quick demo of the solution from the customer's perspective on the support portal. So we can see just a few examples of the ways that this can be used by customers to self-serve. And what I'll be discussing today is the underlying technical architecture that was put in place to support this user experience. So kind of what you'll see first of all is that search is really centered on the page. That's the main focus, is making sure that you search for the problem that you have. When you make a search, we have an AI-powered answer generated for you in real time, as well as references to other sources like user manuals and also videos and other content that you can use to kind of help. You can see that the breadth of questions that people can ask is quite wide. They could be asking about cleaning and maintenance or sort of tips for getting the most from their products, or they could be asking for support with problems that they're encountering with them. So there's a wide range of question types, and also a wide range of kind of answer styles that come out from the AI service as well. Some are kind of short and quick and simple, and others are a little bit more in depth depending on what the customer might need. And as I say, we also have the ability to have videos embedded directly in the content as well as in this example. So hopefully you'll agree that the user experience there is sort of really engaging, really easy to use, and it's a great way for people to get support. So what I want to talk about is what does the architecture look like behind the scenes to support this customer experience. So first of all, there are two main elements to this solution, as I've already touched on. The first is actually the collection, the processing, and the storage of knowledge content that the AI search can use to provide support to customers, and we call that the ingestion side. And then there's the actual front-end user experience that we've just seen. So the services that support the understanding of customer questions, searching for relevant content, and then generating and displaying answers to them. So that's the search side. Both of those areas of the application use different services and are broadly separate in terms of the infrastructure they use and the way that they're configured within Oracle Cloud. But there are some services that are shared by both sides of the application as well. So at a high level, we have the ingestion infrastructure. The services that we're talking about here are object storage, OCI functions and container instances, and the AI speech service as well, plus integration cloud to tie some of those services together and coordinate them. And then we have the search infrastructure. So we have the customer portal itself, which is built in Oracle CX service right now. And then we use OCI container instances to provide some of the back-end application service for processing the AI outputs and displaying them to customers. And we're also using ODA, Oracle Digital Assistant, to tie some of those services together and to coordinate the handling of customer questions when they come in. And then finally, we've got the common services that are used across the solution. So an OpenSearch database that forms our sort of master data storage for all of our knowledge content that the AI service can use, and the OCI generative AI services that are used on both sides of the process to embed that knowledge content and also to generate answers for customers in real time. So we'll take a look at some of these services in a little bit more detail now, and I'll start with the ingestion side of things. So here's a high-level diagram of the ingestion process that's used. So there are three main ingestion scenarios. The first one, or on the left, really, we have two quite similar ingestion jobs that are scheduled. These are both Node JavaScript apps. They allow us to ingest CX service knowledge answers, as well as product manuals, so PDF files for all of the models that the portal needs to support. One of those runs in an OCI container instance, and another uses OCI functions, and I'll touch on why we chose those in a little while. And then on the right, we have an on-demand ingestion scenario that allows video content to be ingested as well. Again, this one uses a variety of OCI services. So you can see the object storage buckets, we can see functions there, and the OCI AI speech service. And then these are all coordinated by Integration Cloud as well. But the end result in the middle is that all of this content is inserted into an OpenSearch database, because that's where it needs to be, so that while questions are being asked on the portal, our AI search can find the answers. So the OpenSearch database is the most fundamental part of the solution, really. It allows us to store all of the ingested knowledge content in a way that can be used by the search system. We chose OpenSearch because really it's sort of perfect for this use case. It's exactly what OpenSearch was made for, semantic search rather than using keyword-based searches, which are quite rigid and don't really allow for the variety in the way that people really ask questions to be understood. Instead, semantic search understands the meaning of the words that are being used, the questions that are being asked, and this allows it to sort of provide a much richer and a much more accurate set of results. To support that, it has native support for vector embeddings, which are the sort of numerical representations of how your LLMs understand various pieces of text. The other benefits of OpenSearch for us were that we were able to provision it quickly and easily on Oracle Cloud Infrastructure as a fully managed service. It's very easy to provision and maintain. It's also flexible and scalable. So as we want to add new knowledge sources to it or support larger user groups, it can do that. And it has a great API as well, which allows us to sort of build this entire architecture around it and to integrate it with everywhere we need to. There were some challenges with choosing OpenSearch. The main one really being the learning curve. It's a different type of database. It doesn't really follow the conventions that you're used to if you come from a relational database background. So we needed to be very careful to make sure that the data model we put in place was going to work properly at scale. And we needed to make sure that we were leaning into the best practices for OpenSearch rather than trying too hard to sort of bend it to our expectations for how it should work, coming at it from a relational database perspective. There was some trial and error involved in that, but I think in the end, as a platform, it's proven itself to be really well suited to this application for us, which is great. Here's an example of a couple of the indexes that we have in our database, so that you can think of these as being like tables. So these are sort of where we store our data. How did we sort of come to the architecture that we used in the end for OpenSearch? We had to think about the types of data that we were storing, so the types of content itself, knowledge content itself. How would we store those different types of content, and what pieces of sort of metadata and information was needed alongside that content to make sure the system worked as we need it to as a whole. So we have a handful of indexes, but these two are sort of our most important ones. The first one, the content index, as I say, this stores the knowledge content itself. So it stores the plain text knowledge content as well as the vector representations of it. So that way we can search for relevant answers using vector searches, which are really powerful and semantic, but we can retrieve the plain text and pass that to the generative AI service to be used to help generate answers. Content stored in quite small chunks. One record in the OpenSearch database might represent just a small portion of an overall document. So we also have to store a lot of metadata about each chunk. So that might be things like its position in the overall document, maybe the page number, as well as other information like the URL or other unique identifiers. And those are different depending on the different content types as well. But we need to store those to make sure that we can kind of refer back to original documents when we're generating the answers. And we also have a product manual metadata index. So this one stores metadata about the individual product manual PDFs that we're ingesting. And essentially by metadata, we mean things like an MD5 hash of each product manual. So during the ingestion, we record a hash of each file, and that way we can compare on each ingestion run to see if a given manual already exists in the database, if it's been updated since the last ingestion. And we also store things like the model numbers and product types that each manual is related to as well. So we can use that then to help filter down the knowledge that's being searched for each individual question that's asked on the portal. So for the most part, it's a fairly kind of flat system. These indexes work independently of each other. As I say, it's not a relational database, so we don't run complex joins and things like that. We just search over the individual indexes when we need to. But we do have some fields that kind of reference from one index to another to help us maintain the records properly and make sure we can find the relevant information we need when we're searching. So in terms of ingestion into the OpenSearch database itself, as I said, there are a number of scenarios. This is the first one. This is ingesting answer content from Oracle Service Cloud, CX Service. So this is a fully automated ingestion process. It runs on a schedule, and it's all contained within a single OCI function. The function isn't too complex, really. It makes a call to CX Service to get all of the answers, knowledge base answers. We apply some filters, make sure we're only getting public answers and only answers that refer to our sort of currently in scope products. We retrieve those answers, we clean up the content, which comes back in HTML format. So we clean it up, remove most of the HTML apart from useful HTML like links, for example. And then once we've got the answer kind of nicely formatted, we split into chunks, and we use the generative AI embedding service to embed that content into its vector representation. And then that data then for all of those answers is loaded into the OpenSearch database. So that's the vector embeddings, the plain text, and the relevant metadata, like the products that are associated with each answer. And all of that runs in that one OCI function. It takes a few seconds at most for each run. So that's something that can be done pretty frequently to make sure that the knowledge base is kept up to date from this data source. The next ingestion scenario is the product manuals, so the PDFs themselves. This is also written in JavaScript, in Node, but this job's quite long running and more complex. So it's not really suited to Oracle functions. Instead, it runs in a container instance. This can actually take many hours because of the large number of products and the large number of manuals that are involved. There are thousands of product models that are in scope of this solution, and each one is associated with at least one product manual. So the application kind of runs in batches. It groups together, 100 or so models at a time, and then it runs for each batch in turn. But within each batch, the application tries to download as many of those manuals as it can in parallel at the same time, so that it can run as fast as it can, because really the main constraint on time here is downloading all of those manuals. And I'll touch on the need to do that a little bit later on as well. But once each product manual has been downloaded, it needs to be processed. The nature of the API we're using means that some of those manuals come back in PDF format, so we can open them up straight away and read the content, but others are actually zip files, and they might contain multiple files within them. So we have to extract the zip file and identify the correct file to process. But for each PDF, we generate the MD5 hash of the file so that we can compare it with what's already in the database. We check, does this PDF and does this model already exist in the database? And then we take whatever action necessary to sort of insert or update the database. And in terms of what actions we might take, that really depends on what data we already have. So this table just kind of illustrates the main options. I won't go into it in any detail, but if the exact same version of the PDF already exists in the database, we don't want to go through the process of chunking and embedding it again and inserting it into the database, because that just takes unnecessary time and cost as well. So depending on the data that already exists, we might insert the PDF, we might insert the model details, the metadata, we might link a model to a new version of a PDF, and so on. But we have to do this check for every model and every product manual that exists. And unfortunately, that does involve physically downloading the PDF files from those internal servers. So the whole process can take a good few hours in total. But in the end, we have a fully kind of refreshed, up-to-date set of product manuals and associated models and product types in the database. The final ingestion scenario handles videos that are being made available to customers on YouTube. Obviously, these are a rich source of information, especially for self-help scenarios like cleaning and maintenance tasks and so on. So we wanted to make sure that they could be included in the search tool as well, so that we could present customers with videos that they could watch rather than necessarily have to read more content. The videos themselves are uploaded to YouTube once they've been filmed and produced, but we decided against trying to download the videos automatically from YouTube. That's because there's not really any decent APIs to do so. So this ingestion scenario instead is invoked kind of on demand. It's not on a schedule. It's not automated in terms of when it begins. So instead, whenever a new video is filmed and produced and uploaded to YouTube, that same raw video file is simply uploaded to OCI object storage as well as being uploaded to YouTube. And the URL of the public-facing YouTube video is added as metadata to the object in object storage. We decided that this approach was kind of the best compromise between the ease of use for staff when they create new videos and the technical effort to build the solution. So once they upload a video to object storage and add the metadata for the YouTube URL, that object storage bucket is configured to emit object events, and that event triggers our integration cloud workflow, which then coordinates the rest of the services that are involved. So first, it initiates an AI speech transcription job, because we need the transcript of what's said in the video to be stored in the database so that we can search for it. So that transcription job takes the video object as its input from object storage. OIC then waits for that job to complete before reading the output, checks the status of the job, and if it's successful, passes that output to another OCI function. That function can connect to YouTube to get metadata about the video, like its full title, for example, so that the staff don't need to type all of those details in. And then it chunks and embeds the transcript of the video just as the other ingestion jobs do. It bundles all that up into a payload that can be inserted into the OpenSearch database. And once that's done, OIC then initiates the call to OpenSearch to insert the payload, and that makes the new video available to the AI search service immediately. So in general, this whole process from video upload through to the record being inserted into OpenSearch takes about 10 minutes, but it's totally asynchronous. So the user doesn't have to wait for it to complete. They upload the video file to object storage, and this just runs in the background. And that brings me on really to some of the benefits that we found from using Integration Cloud for this ingestion process. So first of all, when it comes to triggering the integration, the ability to just enable the object emit events in this object storage bucket and then create a subscription to that so that Integration Cloud is automatically triggered means it's really easy to start the integration directly in response to a new video being uploaded. We didn't have to build any custom REST calls or polling to check what objects exist in the bucket or anything like that. OIC then also allows us to kind of robustly wait for the transcription job to finish. It needs to check its status occasionally and continue only when the job has completed successfully. We also have direct connectors and simplified integration to the native Oracle Cloud services as well. I'll give a couple examples of those in a second. And it's also really easy to implement really robust error handling logic as well in the integration, as well as email notifications straight to the business if anything goes wrong, so they know that something has happened that needs their attention. In terms of the user experience, for those who are uploading the videos, we could have chosen to implement a custom user interface for that, but we decided it wasn't worth the technical effort given the file sizes involved in particular, because there can be many hundreds of megabytes, and uploading those can sometimes be a challenge on different platforms. So instead, we were able to use the OCI security configuration to grant access to the cloud console for the users who are producing the videos, but restrict their permissions so they could only access the relevant object storage bucket. So that means that we can train them to easily log into OCI, navigate to the object storage bucket and upload the files directly, which is really easy for them. So in terms of that integration with Oracle Cloud Services that I mentioned a second ago, the OCI AI speech service is one example where this is much easier with Integration Cloud. So the AI speech service is accessed through its REST API. So you create a new transcription job by firing off a REST request. You point it to an object storage bucket that contains the video file. Now, this API uses the sort of newest OCI REST security methods where the requests need to be signed with a private key prior to being sent. It's a really secure method, but it can also be quite challenging to implement sometimes. Depending on where you're calling the API from, it can be tricky because you need to use the OCI SDKs and complex sort of crypto libraries to write code to sign the requests. It's quite easy to get it wrong, and to spend hours debugging those sort of requests because you're not quite signing and collecting all the data correctly. So one of the benefits that OIC Gen 3 brings is that it has native support for this kind of authentication built in. So for these OCI REST APIs, you can create a REST connection and you can choose the OCI service invocation security policy. And then what you're able to do is you can grant access to the REST APIs through the usual kind of OCI identity and access management methods. So you could create a dynamic group, for example, and add the OIC instance to that dynamic group. And then you can create a policy to grant that group access to the AI speech services. So then there's no need to deal directly with private keys. There's no need to have any code to sign your requests or anything like that. It's all just configured directly in the OCI console. So that makes setting up these integrations much simpler, much quicker. Another example of this is the integration with OCI functions, and this one's actually even more streamlined than it is for the speech API, because it uses a fully native connector in OIC Gen 3. So there's no need even to create a REST API, a REST connection at all. Simply use the native OCI function connector, and all you really need to do is input the details of the function that you want to invoke. So the OCI details like the compartment it sits in, the application it sits in, and then the name of the function itself, along with any input parameters that you need to provide into the function. And then the integration just works. So there's no need to deal with the underlying REST configurations at all. No need to, again, deal with the request signing or anything like that. All of the access is controlled through the same OCI groups and policies natively. So that meant that using functions with OIC was really, really easy. There were some other considerations and challenges related to the creation of these pipelines that I thought I'd share. So the first one is that, these are quite complex processes that are running. They do require a level of familiarity with the core concepts behind sort of LLM-based applications. So chunking your content, creating vector embeddings, for example, and the sort of implications of the design decisions around those, such as how you design your LLM prompts and instructions and so on. As well as the sort of various technical libraries and tools that support those processes, like the LangChain libraries, for example. Another aspect is that, from a technical perspective, most of this stuff's generally done in Python. So if you're not familiar with Python, then that's something you might struggle with, especially because obviously there's far more to think about when you're building something that you're intending to put into production. We found that the JavaScript versions of many of these libraries were suitable for our use cases, which was really helpful because we have a lot more experience in JavaScript. So we preferred to use that when we could. There are some limitations to those kind of libraries, but you might find that they're perfectly suitable for what you need. Another thing to consider is that really you're sort of at the mercy of your existing data sources. So wherever you want to pull your existing, your knowledge from, your existing knowledge sources, you really need to have a good idea as to whether, first of all, that knowledge content is actually high quality, which is really important to consider, but also how accessible is it? What do your APIs look like? Are you able to access the content and the metadata around it easily? If you're using fairly modern data sources like, Oracle CX, for example, or, other external tools like SharePoint, then you're probably going to find it much easier. But if you have a legacy tool or an obscure tool that doesn't really provide you with a convenient API, then you might struggle. One of the challenges we had, as I mentioned before, was that we couldn't retrieve any metadata about our product manuals, things like the last modified date, for example, without actually downloading the entire PDF file itself. And that could be many megabytes in size. So that's quite inefficient and it it leads to the process taking a lot more time, but unfortunately was just something we had to deal with. But that's something that's pretty important to try and understand right at the start of this process is what kind of access do you have to your knowledge content and how easy will it be for you to keep it up to date? So that was the ingestion process, which is the sort of main part of the process, really. But I also wanted to take a quick look at the infrastructure that surrounds the actual search process as well when customers ask questions on the portal or in the chatbot. So as you can see, we have the customer portal, and this is CX Service Cloud, and we have ODA. ODA in particular sort of coordinates all of the incoming searches. I'll explain a bit more about that in a second. We have the OpenSearch database and the generative AI service. Plus, we also have a WebSocket server that we've hosted in an OCI container instance as well, which allows us to stream the answers back to the customer portal in real time. So in terms of ODA, as I mentioned before, ODA triages all the incoming questions, whether they're asked from the search bar on the customer portal or through the chatbot. They're all sent to ODA. ODA decides how each question should be answered. It does that by taking advantage of its built-in intent recognition. It's trained on a number of common question types and request types. So in many cases, it will follow static paths to present the customer with their answer. It might redirect them to other pages, like the online shop, for example, or it might redirect them to the repair form. If they've mentioned a known fault that we know can't be fixed through self-help. It can also ask for clarification. So even through the search bar, if the customer says something vague, like if they just say that their product is broken, they can be prompted to explain the problem in more detail. And the second time around, they might then describe the fault itself. They might tell us the door's jammed, or they might provide an error code or something like that. And that gives us a much greater chance of actually providing them with accurate answers. So ODA kind of controls all of that triage process, really. And it also handles some of the interactions on the page as well through the Web SDK. So for lots of scenarios, we know in advance how we want those questions to be answered. But in other scenarios, ODA instead hands off to our new AI search architecture, which can try and find an answer from the full range of knowledge sources that we have available in our OpenSearch database. So to do that, the first thing, as you can imagine, is to validate the customer's request. We need to make sure it's on topic, it's in scope, and most importantly, we need to make sure it's safe, because we're going to ask the generative AI service to write a response. So we should make sure that the user isn't trying to ask the LLM to do something it shouldn't. They're not trying to work around the guardrails or the rules that we've put in place. So that validation is done by the LLM service itself. We ask the generative AI service various questions about what the user has typed in. So we can use the output of those questions to judge whether the inputs are safe and on topic. That, those results aren't shown to the end customer. They're evaluated in code, and there are multiple levels of validation that are applied at that point. So we're able to remove the risk of, off-topic or inappropriate answers being presented to customers. But once that validation is successful, then we search our knowledge base for any related content. And as long as some useful content is returned, we can then move on, because we know at this point we've got both a valid in-scope question from the customer, and we've also got a valid set of content from the knowledge base to inform their answer. So then at that stage, we're ready to prepare the answer. So this is when we create a prompt to tell the LLM how to answer the question. We take all of the relevant knowledge content that we've retrieved from OpenSearch, and then we bundle that together and we save it in what we call an answer preparation record in our database, and we return that answer preparation ID back to the browser. And so at this point, the browser receives the answer preparation ID, and now it opens a dedicated connection to our WebSocket server, and that server is hosted on OCI in a container instance. And when the WebSocket server receives that request, it looks up the answer preparation record. It sends the request to the generative AI service, to the LLM, and then it streams a response back to the browser as it's generated. So by using this architecture, this sort of two-step approach of first validating and preparing the request and then generating it directly from the browser, means we can apply really robust validation of the request first and make sure it's safe to generate an answer in the first place, but without actually generating it. And that's important because it's much quicker. So when we do want to generate the answer, we can just stream it out directly to the browser as it's being generated, which massively improves the performance for the customer, but without risking us, showing them anything dangerous or out of scope. So without this approach, we'd either have to wait for the entire answer to be generated first before validating it, which risks us presenting inappropriate content to the customer, or we'd have to generate the entire answer in the background, then validate it before presenting it to the customer, which would sort of hugely impact on the performance from the customer perspective. So that's why we took this approach of an intermediate WebSocket server to handle the streaming. Just some considerations about this side of the architecture that I'll mention briefly. So the first is that we instruct the generative AI service to write its answers in Markdown format, and then we sort of parse and sanitize and convert that to HTML when we display the answer. That means the LLM's free to use rich formatting as it sees fit, so subheadings, bullet points, numbers, and things like that. But it prevents dangerous content like HTML and JavaScript from being injected into the page. We do provide citations, so the customer can refer to the original documents that have been used. And as I mentioned earlier, we do have the LLM carry out a number of background tasks for us, like validation. When we use the generative AI service for that, we use JSON schemas to force the LLM to provide output in a certain format for us, which means it's much easier for us to evaluate the outputs in code, and it's also much quicker than waiting for the LLM to write sort of long prose. So you can see an example of a JSON schema that we use for that purpose here. And another final consideration in our architecture is that by using the WebSocket server, we were introducing a new connection directly from the customer's browser to our container instance. And that container instance was hosted outside of Service Cloud, outside of CX service. So requests like this are blocked by your browser by default. They're prevented by cross-origin policies. So to resolve this, we had to place the container instance behind a load balancer on Oracle Cloud. Then we created a new subdomain for the WebSocket server under the customer's primary domain. And that subdomain's DNS record we pointed to the Oracle OCI load balancer. Then we uploaded the customer's own SSL certificates to the load balancer, which meant that secure WebSocket connections could be made from the browser on the customer portal page into the WebSocket server. So that was sort of the final piece of the puzzle that allowed us to build the nice kind of streaming interface that you saw in the video earlier on. So that's an overview of this solution. To summarize, we built a new RAG style AI search feature that customers could use on the support portal, which was kind of reimagined and redesigned with a new search first design. To support that, we made use of a whole host of services on Oracle Cloud to support both the ingestion and the search workflows. So core services like object storage, OCI functions, AI speech, and others, which were then sort of tied together with Oracle Integration Cloud and Oracle Digital Assistant, and all pushing content into an OCI managed OpenSearch database. So that's everything that I wanted to cover today. So I hope you found that interesting as a look at the architecture that we chose. And Jürgen, back to you, I think.
Jake, wonderful. So it's an exciting project where you use Oracle integration to orchestrate AI services.
Yeah, exactly.
That's a brand new use case. And you use also Oracle integration to make AI actionable and to generate a service portal.
At the moment, we don't use it on the search side in Integration Cloud, only on the ingestion side. But we've got lots of, there are plans for new features in future. So I think that there will be more use of Integration Cloud on the actual sort of customer interaction side as well.
How many % of the questions can you answer through the portal?
Oh, that's a good question. I don't have that number off the top of my head, but it has significantly reduced the number of sort of repetitive questions coming into the contact center team, and I know that it has improved the quality of self-help answers, which means that fewer repair requests need to be actioned as well.
Excellent. So before we come to the questions and answers, if you would like to know more about Boxfusion, you can visit the website. There you find also details about the integration cloud offerings from Boxfusion. If you would like to try Oracle integration, make use of the free trial. At the documentation page, you can find the live labs to build your proof of concept. And we have plenty of information at the website and at our blogs. To get the latest updates, please subscribe to our newsletter. So if you have questions, you still can post them in the Q&A tool. There's one question from Marcus. He would like to know if you make use of AI vector search in your architecture.
We do through the OpenSearch database. So that database stores vector representations of all of our knowledge content. We've used our own pipeline to embed the data into vector embeddings and then load into OpenSearch. So this solution, for example, doesn't use the OCI managed AI agents service, for example, because it was built a little bit before that was made available. But we could definitely supplement it with that service in future if we wanted to. And that, I think, uses an OpenSearch database behind the scenes as well.
Okay. Next question is on Digital Assistant. Are you using the standard UI or did you build your own interface?
So the Digital Assistant, we're using the ODA Web SDK for chat itself. So we are using the out-of-the-box widget for that. And then we modified slightly the search widget on the customer portal so that it would send requests to ODA rather than to Service Cloud, and that's how we made sure that ODA could handle those requests first. And again, that uses the ODA Web SDK.
And is ODA connecting directly to the database or are you using integration to orchestrate it?
ODA at this point is connecting directly to the OpenSearch database. Yeah, so we have a component within ODA that sort of orchestrates the search of knowledge content, takes into account the history of the conversation or the history of interactions that that user has had, and any products they might be looking at on the website, and then it feeds those into the search of OpenSearch. So it does integrate directly with OpenSearch at the moment.
Excellent. Thank you very much for the excellent presentation. If you have further questions, you can contact Jake or myself anytime and make use of the resources. There you find all information for customers and partners. If you would like to reach out to our team, Neil Kominski is the product manager in EMEA, Paulo Muta in South America, Ravi Chaplani in the US, Ravi Pinto in Asia, Steve Tyndall in Pacific, and you can reach out myself for any kind of partner questions. Jake, thank you very much for the excellent presentation. We hope to welcome everybody again for the next webcast on October 8th, and hopefully we see you also at Oracle Cloud World. Thanks for the wonderful presentation, Jake.
Thank you very much.
Thanks for attending.